one of them's sick and the other one has their dog ate chocolate and they rushed him to the vet. And anyways, didn't know the vet was open this late, but
oh well.
So we're going to go ahead and start. What I'd like to do is go back to the idea of structures in classes, because the more often we go and see that, the better off we are. So what letter are we on now? We're on QRSTU. That's what y'all were just talking about.
Lecture uniform.
We're putting U into lecture. Alrighty. I'm sure there's some cool pun there.
What?
Empty project. Lecture U.
Well, it looks like we're meant uniform.
Alright, so what are we going to do? This time I want to make a fraction class. And a fraction has a numerator and a denominator. The numerator being the thing on the top and the denominator being the thing on the bottom.
Oh, there you go. I wish I could derivatives class next, guys. All right.
So I'm going to make a C++ file, of course. Going to be grabbing my boilerplate really soon. It's not lecture T, it's lecture U.
Lecture T.
I have a suggestion, Professor.
Yes, sir.
The next class, we should do a derivatives class.
Yeah, I'll let you teach it.
I think he meant programming derivatives.
Yeah, that would, yeah. It's been too long for me.
You actually do that?
Yeah, you can.
You have to do that.
All right. So, oh, I keep forgetting to go and get my boilerplate.
If you can't do that, then why teach you? Why does computer science teach you to count 1, 2, 3, 4 anyway?
I couldn't tell you. I just don't have to take it.
I guess add the source file.
Yeah, add a source file, do the usual boilerplate.
You know how cold it is outside right now? Or?
How cold is it? All right, so let's make a class called fraction, and it just has two integers. I'm going to call them N and D for numerator and denominator. We could call it T and B for top and bottom, but N and D. I'm kind of liking top and bottom all of a sudden. Class fraction. And we're going to make all the variables public in it so that we can access them inside main. If we made them private, then main wouldn't be able to touch them. So public colon.
When is the only time you can make it private?
Yeah, that's going to be a good topic, and that'll be a lecture in and of itself. For now, we're not going to make them private. All right, so we have a top and a bottom. And here's what I want to be able to do. I want to be able to make fractions like this. I want to be able to say fraction f1 and then say that the fraction is equal to 3 over 4. That's my goal. But I can't do that unless I have a constructor that'll accept these pieces of data. So I'm going to add a constructor. A constructor is a method. What is a method? It's a function that's part of a class that has the same... Oh, you just shut up. All right, so a constructor is a method that has the same name as the class. No return type, and is called to create a new object. So we're going to add a constructor. The constructor has the same name as the class, fraction. No return type, so I'm not going to stick the word int or void or anything in it. And since I want to be able to call it like this with these variables,
function.
I need to do int top, comma, int bottom. And it needs to set these member variables. These variables are part of the class. The constructor is going to set their values. This hyphen greater than top equals top. The top that's passed in as a parameter. This hyphen greater than bottom equals bottom. So when we say this, what it's referring to is a variable that's part of the class, right? So this hyphen greater than top is equal to that variable. You can even tell by the colors, right? This one's gray, so it's referring to that one. This one's black, so it's referring to that one.
Oh wait. Bottom equals bottom.
I'm going to move my code past that comment so that all the code's on the screen at the same time and the comment's not. There. Alrighty. Now there's two ways of creating objects. That's one way. That's the kind of, and then there's a way that'll look familiar to Parker for being a Java programmer now. Using the new keyword. So if you use an asterisk, it creates what's known as a pointer. Well, what's a pointer? It's a memory address. This is actually an object, right? This is a fraction. This is a pointer to a fraction. It's the address to the fraction. Why do we keep saying address? Well, this is like my house, and this is a pointer to my house, the address of my house. If I give you my address, you can still go to my house, you know, and break the windows or whatever, and now I have a house with broken windows. It's a different syntax to access the pieces of this object based on whether it's a pointer or whether it's the object itself. I'm going to comment this one out for now.
Comment it out.
Yeah, and then I'm going to run it and make sure I don't have any syntax errors.
Can you check something out real quick? Oh, once you're finished.
All right, no syntax errors. I'm happy about that. Yes, sir? Pardon?
Can you check something out for me?
Yeah, I need to come look. Sure.
Yeah. Oh, I put it.
A couple of things I'd like to do. One is I want to add a method that'll print it.
Just do a cout.
Yeah.
Or we can do a function.
So here's what we're going to do. Yeah, it's going to be a method that has a function. Excuse me, it's going to have a function which uses cout. And a function that's part of a class is called a method. It doesn't need to return anything because it's just printing. So this is the end of my class right here. I'm going to put a little comment so I don't accidentally do what Parker did and stick it below the class, which I'm honest I do all the time as well. All right, so void print, parentheses in parentheses, and we want to print out our fraction. So cout less than fraction equals end quote less than top less than quote slash, right, just so that, you know, if it says 1 2 it'll be 1/2 less than bottom less than ENDL. Well, I didn't call the print function. I got to go back down to main, and after I create that fraction, I need to call the print function. So I'm going to come down here, and after I create my fraction, I'm going to say f.print. And I'm hoping it'll say 3/4. Yep, 3/4. All right, my next little project. If I say 2/4, what does that really equal to? That's 1/2, right? The other cool thing would be if we had something that would calculate the value, right? 1/2 is equal to 0.5. So let's write a method that returns a value. Now, if it's going to return a value like 0.5, does the function have to be an int or a double? If it's going to yep, exactly. So double space value, parentheses in parentheses, and let's just return the top divided by the bottom. And let's hope that the bottom is not set to 0 because it'll crash.
Everything crashes with 0. I'm just kidding.
Well, anytime you divide by 0, the results are not good.
In mathematics, it doesn't exist.
Well, let's call infinity.
All right, and so let's get the value of that, right? Down here, double v is equal to f dot value, parentheses in parentheses, and then let's print out the value of fraction f is, end quote, less than v, less than e and dl.
I think we need to create a left assign 1 and 2, though, right?
Yeah, we could create another fraction that was equal to 1 over 2. Now I goofed. I made a mistake. Why did it say 1 over 2 was 0? What are the types of top and bottom? Top is an int, bottom is an int. What happens when you divide an int by an int?
It
rounds.
You need to do a double.
It rounds down, exactly. So what we're going to do is we're going to declare a double space result equals top, and then top equals top divided by bottom, and then return result. Now I could have done it easier. I could have done a cast, right? I could have just done it like this. Let's use a cast. Double, return, double parentheses top divided by double parentheses bottom. In other words, treat them like doubles rather than ints. Now it's better not say 0. Okay, and 3 over 4 is 0.75. Very good.
Can you go down your code for 1 second?
Uh-huh.
I couldn't figure out the last one on homework 7 or homework 8. I couldn't get the string convert to numbers or whatever, so I just like type 555 or something like that for whatever.
Well, maybe we'll go look at it. But for now, let's finish with this one, because there's a couple more things I want to do. One is I want to be able to simplify it so that if it says 2 over 4, when we print it out, it says 1 over 2. So we need to add a simplify method. Now this is where it gets complicated, because if you're going to simplify, you have to know the greatest common factor. And sorry for getting mathy, but I know that most of us are math fans, and so in order to simplify 2 over 4, you have to calculate the greatest common factor. And the greatest common factor of 2 and 4, the largest number that it will divide into both of them is 2. And then you divide both the top and the bottom by 2. So we're going to need a function that calculates the greatest common factor.
You need a method of GCF in the class.
Yeah, so we need a GCF. It could be a method that's part of the fraction class, or it could just be a function. Let's just make it a function. So I'm going to put it above the class.
Above?
Yeah, and it's going to be an int, and we're going to call it GCF, and it's going to take two numbers, like x and y. Int x, comma, int y. Now the only reason I know how to write this code that I'm about to do so quickly is because I wrote a GCF function just the other day, and so it was fresh in my mind. What am I going to do? I'm going to start at the lower number, and then start going up to the larger number until I find the largest one. that will divide into it. So int start equals x. Int result, which is the GCF, I might even just be able to say int GCF equals x, right? Because it might just be, no, it's actually going to be 1, right? We got to start at 1. So I don't know why I said int start equals x. Okay, I was bragging that I knew how to write this, and now my brain is messing up on this.
No, you're fine.
So what we're going to do is we're going to have a while start is less than y, or maybe even less than or equal to y. We could probably write this as a for loop. I like for loops. I'm going to erase that start message and that while message, and we're going to implement a counter that counts from 1 up to y. So for int I equals 1 semicolon, keep going while I is less than or equal to y. I guess I'm assuming, and this is a bad assumption, we need to know which is higher, x or y. Fortunately, there's a function for that. So we need to figure out the max value that we're looking for. I believe it's in the math class. I believe that we've already included it, so I think I can do this. Int max equals the maximum of x comma y. And it's complaining. Why is it complaining? Standard colon colon max. Huh? Finds the largest value from 2 given values. Maybe I shouldn't have called it max then, huh? Let's give it a variable, a different name. End, right? Because that's going to be the end of the loop. Or actually, we could go for the minimum. Right? Because the greatest common factor between 2 and 4, it can't be 4. It could only be 2. Standard colon colon min? Why is there no min function? There's f min. Include algorithm. All right, we have a brand new include. Okay. So go up to your code and do # include algorithm. # include algorithm. I wonder if Al Gore is fond of the fact that his name is part of math.
Do we really have to call the header file for std for every line? Because that would
No, we don't. I was just trying to figure out why this wasn't working, and so I took a stab at seeing if that would fix it. It didn't. If we took this out, we would have to, right? If we commented that out, all of a sudden we got a million errors we'd have to fix by putting std in front of everything. But we're smart enough not to comment that out. Okay, so we start I at 1. We keep going as long as I is less than or equal to the end. I++. And if x divided by I is an even number, or what I mean is no remainder, and if y divided by I has no remainder, then it's a GCF. And so we need to update our new GCF. So if x modulus I equals 0, and then what's the symbol for and?
What happens to the start one?
I got rid of it.
There's no start.
Yeah, I got rid of that variable. Sorry. So what's the symbol for and?
Ampersand, ampersand.
Yep, ampersand, ampersand. And so if x modulus I is equal to 0 and y modulus I equals 0, that means that it was evenly divisible by both of them, right? So if I is equal to 3 and x and y are 6 and 9, then 6 modulus 3 is 0, that's true. And 9 modulus, not 1, that was a mistake. I meant to type in an I there. Please make both of these moduluses equal to I. And if both of those conditions are true, we have found our new greatest common factor.
If that's false.
If it's false, we're just going to keep counting. So we don't need an else. And after our for loop, we have found it. So we're going to return our GCF. Now maybe this should be part of the fraction class, but it seems to me like this is a completely different topic, right? Well, I don't know. We could move it into the fraction class. That'd be real easy, right? We just copy and paste it.
Yeah.
Why don't we do that? Let's put it in the fraction class. Just cut the whole thing after you get your closing braces and all that. Cut the whole thing and put it inside the fraction class. Compile it to make sure it doesn't have any syntax errors, even though we're not using GCF yet. Error list, woohoo, I sure do. All of a sudden it doesn't know what the fraction is. That means I have too many closing braces or not enough or something. Yep. You see what's wrong with my code? It's underlining it even, so what's wrong with my code? I got a closing brace that didn't need to be there. All right, now to run. All right, so it compiles. I want everybody's code to compile before we continue. Anybody need to see a particular function on the screen? Are we all good or need help?
For min, it says it's underlined in red, so I'm not sure what's going on.
Did you get this here?
Yeah.
Well, then let me come look. All right, so scrolling down so that y'all can take a look so far, the folks at home. Here's the top of our fraction class. What'll get you the most is your opening and closing braces. So I'm going to start adding some comments here. This is the end of the constructor. This is the end of the print method. And you may think it's obvious, but we've already seen some problems with closing with curly braces, and I get them all the time. This is the end of the value method, and this is the end of the GCF method, which makes that the end of the fraction class. And in this language, unlike Java, all your classes have to end in a semicolon. And you certainly don't have to put functions inside of a class, right? It's only because we're writing a class that we're sticking the functions in there. The GCF function could have been put inside the class or outside of it, and it would work just as well either way. All right, so now that we have a GCF, we can write a simplify method. And what is simplify going to do? It's going to get the GCF, right, like 4 over 2, the greatest common factor of those is 2, and it's going to divide the top by that number and the bottom by that number. It doesn't need to return anything, though. So we're going to make the simplify method void as well. I mean, it could return something. It could return a value, but that's not really its point. That's not its purpose. So void simplify. We got to get the GCF. So int GCF equals GCF parentheses in, whoa, where'd all those come from? Parentheses in parentheses. Oh, we got to pass the numbers in, right? Top, comma, bottom. I'm getting an error here.
You shouldn't be getting an error.
Expression preceding the parentheses of a parent call must have a pointer to function type. We keep getting this over and over in different places. And I know what the problem is. What was it when one of y'all had that? I think the problem is that it's the same name as that. So let's call it factor. Int factor equals GCF, comma, top, bottom. And then let's divide the top and the bottom by the same thing. So this hyphen arrow top. And just like you can use plus equals or minus equals, you can use divided by equals. Divide the top by the factor. And this hyphen greater than bottom divided by the factor.
What does slash equal mean?
It's the same as this. If you have, a great question, what does slash equal mean? If you have x slash equals 2, it's the same as writing x equals x divided by 2. It's a shortcut for saying that. Just like if you have x plus equals 2 like you did in Python, that means x equals x plus 2. Is that making sense? All right. Okay, so we have a simplify method. Let's test it out after we create our fraction. Let's call it f.simplify. Now it probably should simplify itself, right? We probably shouldn't have to call it. But for now, we'll just leave it like that. Yeah. As a matter of fact, I don't think I want to work on this anymore, so I'm going to leave it like that. The right place to put the simplify call, though, would be in the constructor. If we went up to, I'll be right over. If we went to the constructor and simplified it after we set these values, that'd be right. Because after the constructor calls, if the top is 2 and the bottom is 4, then we'd like to simplify it to 1/2. So if you feel like it, put a call to simplify right there. If you don't, fine.
Okay.
And we could be really cool and make an invert function which swaps the top and the bottom. We could make a function that let us multiply 2 fractions together or add 2 fractions together or divide 2 fractions. That might be the last one we do. I kind of want to do a multiply function and then leave it alone. All right, so let's make a multiply function.
Wait a minute, you resumed recording, didn't you?
I think I did. Yes. Okay, thank you for reminding me because I'm perfectly capable of not doing that. All right, so multiply is going to take a fraction as its parameter, and it's going to increase the top and the bottom by multiplying them by the fraction that's passed in. So, I don't think this needs to return anything either. Void multiply, and we want to multiply our current fraction by another one. So fraction, can I type? Nope. Fraction other. So we're going to say this hyphen top times equals other hyphen top, and this hyphen bottom times equals other hyphen bottom. So this minus greater than top times equals other minus greater than top semicolon. Because that's how you multiply fractions, right? You just multiply the tops. Although I'm getting an error there because I need to make that a dot. And I'm sorry for the change in syntax. Let's fix that by putting a star here. And I'll explain what that means at some other point. All right. In this hyphen greater than bottom, star equals other hyphen greater than bottom. But after we multiply it, we better simplify it. Right? Like if, you know, sometimes when you do your multiplication, you get a fraction that's not simplified. So simplify.
And can you view it in the debugger or whatever?
Like we want to step through it? That'd be cool. But let's first add a call to multiply. So we're going to need a second fraction unless we're going to just multiply it by itself. Which we could, right? But let's create a second fraction. So fraction, still can't type today, F2, we're going to multiply this one by 8 over 3. And so F dot multiply by F2. And let's see what the result is. All right, I am very sorry for this, guys, and I'm sorry for the alien syntax. It looked better in Java where we did not have to switch between using the hyphens and the dots. Remove that asterisk there, and we'll just give in and do a dot there and a dot there. And I'm going to have to explain the difference between using the arrow greater than and using a dot. You use arrow greater than if what you're talking about is a pointer. And you use dot if not. I'll give you an example of that in just a minute, but I want to see if it prints out whatever 2 over 4 by 8 over 3.
Can we keep the original one too, or do you want us to get rid of it?
Okay, if you want it done the way that I was originally cooking it up, to get it to work, you would have had to put in an ampersand right there. And that looks a little bit dumb. That's why I went and changed it the other way. If you feel like putting the ampersand there, that means address of. I'm going to go with not doing it that way. And then in a minute, I'll explain the difference between dot and the arrows. All right, so 2 times 8 is 16. 4 times 3 is 12. And what is 16 over 12 when it's simplified? Yeah, it'll be 4 over 3. So after this multiplication is done, that's when I'm hoping it'll print. Yep, 4 over 3. All right, we have a working function class. And what I could tell you is that since I did the easiest one, multiply, I can make it your homework to do add and subtract and divide. But nah, let's not do that. Is it working for everybody, though, or anybody need me to look at your screen? Okay. So, to do division, it's the same thing as multiplication, except you multiply the top by the bottom and the bottom by the top. So I'm going to copy the multiply function, paste it, and rename it to divide. And top times equals other dot bottom. And bottom times equals other dot top.
Do you think it's going to screw up the computer?
So Parker, we honestly could have gotten the pointer to work with the ampersand. We had other problems going on with Visual Studio. Okay, so if we want to test divide, to me it seems like, how could we test divide? What are we going to divide by in order to see what it, let's just divide it in half. Because 4/3 divided in half is 8/3, if I understand. No, it's 4/6. So we're going to have to create another fraction and call divide. Has everybody got this one where it'll compile?
Let me see. There we go. Mine's compiling.
All right. Slow down or go, can we test, can we add the code?
Mine doesn't.
All right.
I can't wait to get out here because I can just.
So let's divide our fraction by 1/2. So let's make one more fraction. Fraction f3, 1, 2 is going to equal 1/2. And then we're going to say f dot divide by f3. So it's going to divide our last one by 1/2. And then I want to print it again. So f dot print like that. I'm going to add a blank there just so that we can read what it's doing. All right, and so it is true that 4 divided by 3 divided by 1/2 is 8 divided by 3. Now that's counterintuitive. How can we represent the number 2 as a fraction? 2 over 1, right? Because I divided by 1/2, but I forgot that dividing by 1/2 is the same thing as doubling. I didn't want to double it. I wanted to actually chop it in half. So I'm going to make a fraction that's equal to 2 over 1 and then divide that, because that's just 2 over 1 is 2. And then when we divide that, that's the same thing as dividing by 2. And it worked, right? 4 over 3rd, and we divided it by in half, and so it's 2/3. Now adding and subtracting is a little bit more complicated. I don't feel like doing that. What you got to do is multiply both sides times the numerators.
Well, both sides
by the denominators, yeah.
Yeah.
Yeah, and I'm not going to do that. I think we've gone far enough on that. But I do want to talk about the difference between the dot and the arrows. Java does not have that distinction. This language does. So you use the dots when you have an object, and you use the arrows when you have a pointer. So what the heck is a pointer? Let's make a variable called x and set it equal to 3. And let's make a pointer to x. So int star px equals ampersand x. So px at this point is not an integer. It's the address of an integer. Whatever address x is stored at in memory, it's now holding, because that's what ampersand means. It stands for address if it's just 1 rather than 2. It gets the address of x and stores it. So let's print out x, and then let's print out px. Cout less than x, less than quote space quote less than px less than endl. All right, and see, the value of x is 3, but the value of px is that really weird number, because that's the address that the x variable is stored in. So it's a strange concept. If I wanted to print out the value of x based on its pointer, I have to do something that looks strange. Cout less than star px less than endl. Star px and x are the same thing. What the star means is jump to that address and then treat it like a variable. So since px is equal to 8 million, or whatever that number was, it was a memory address. If you stick a star in front of it, it turns that 8 million back into a variable that it can use. And so now it's going to print out 3. You know, we could put some explanation here, like less than star px equals end quote less than, right? And here we could say px equals, right? And so x is equal to 3. The address of x is equal to 570 million, or 570,000, whatever number that is. That's the byte address in computer memory. And then if you go and peek in that byte address, it's got a 3 stored there. That's what a pointer is it's a memory address. It's got a number like that in it. And then you can peek around inside the memory address to find out what's at that specific spot in memory. So we have this fraction called f. We can make a pointer to that fraction. Fraction asterisk p f, it's a pointer to the fraction, is equal to the address of f. What does ampersand mean? Ampersand means address. So it gets the address that that fraction variable is stored in and puts it in this pointer. So we could print out that address if we wanted to. Cout less than quote pf equals end quote less than pf less than endl. And we're going to find out what memory address pf is. It's going to be in a different place than px because they're not pointing to the same address in memory. They better not be anyways.
Or else our computer's going to crash.
Well, they're not going to crash, but okay. And so they're close to each other, right? They're close to each other in memory. But if they were the same numbers, it would mean that that x and that f are the same thing, and they're not, right? Because x is an int and f is a fraction, so they better not be just sharing the same memory because they're completely different data types. Okay, so we have a pointer to the fraction, and we have the fraction itself. If you want to change the top or the bottom of the fraction, you could do this. F dot top equals 4. F dot bottom equals 6. And now let's simplify it. F dot simplify, and then F dot print. Now we're going to access the same object by its address using the pointer. So the difference between an object and its address is I have a house, but I could give you the address to my house, and then you could use my house if you knew what the address was.
You can break the windows.
Yeah, please don't. All right, so PF dash greater than top equals 12. PF hyphen greater than bottom equals 4. PF hyphen greater than simplify, and PF hyphen greater than print. So let's add some comments. Use the dot notation when accessing an object. Use the hyphen greater than notation when accessing a pointer.
Wait a minute. Oh.
So in that function where we were multiplying and stuff like that, that keyword there means address of the current object. It requires pointer notation. And so that's why we're using hyphen greater than, because pointer notation requires you to use hyphen greater than. But this fraction is not a pointer, it's just the object. And so that's why we accessed it with the dots. It'll make more sense the second time we see it, but I did want to bring up the idea of what a pointer is. One more thing I want to show you about pointers is that you can use them to actually change the values of a variable. And we're just about done, but I'm going to write a function called change me, and it's going to take a variable like int I, and it's going to try to change it. I is equal to what? 200. And then I'm going to try to call it. Int score equals 100. I scored 100 points. I'm happy about it. Now change me score, because I want to set my score to 200. I want to be even more awesome. It's not going to work. If I see out, quote, score equals, end quote, arrow, arrow, score, arrow, arrow, ENDL, it's going to print out 100 still, even though we called change me.
What the?
Let me prove it first. Yeah, it's still equal to 100.
I just accidentally stepped on it.
But if we pass in score as a pointer, we can change it. Why isn't it changing it here? Because it got passed in as a copy. Score is equal to 100. It's got the value 100 in it. So that 100 filled in I. I is not the same thing as score. I is a copy of score. It's like I have a dollar bill and I give you a copy of it. You tear it up, no problem. I still have my original value. So he's trying to change something, but he's not changing him. He's just changing his local variable called I. So it does not affect that variable. That's why when we print it out, it still says 100. If we want to actually let the function change it, we can do it by pointers, which would look like this. Void change me to parentheses, and we're going to declare a pointer instead. And to declare that pointer, you use that asterisk like we were doing below. And I'm going to call it PI, meaning a pointer to I. And then I can say star PI equals 200. Star PI means going to that address and change it. So it goes to the address of PI and changes it to 200. So if we call change me to and pass in the address of score, ampersand of score, and then print out the score again, we'll see that it actually is 200 now. So if I added a comment here, it would be pass the parameter in by address. And I'm going to add the comment here, PI is a pointer to the address of an int. And then change the int by using its address. There's a fancy word for using this asterisk in front of a pointer called dereferencing. I don't quite know why, but this is dereferencing a pointer to set the value of the thing that it points at. So you can go and break my windows. You have my address, right? We have the address of that integer score, so we can go and break its windows. We can change its value. And the second one worked because we passed it in by address using the ampersand, which means address. Now that'll seem a little bit esoteric, and the second time we see the explanation, it'll make more sense.
In about 4 minutes.
All right, so I'm going to scroll from the top to the bottom. Of course, you can always look at the notes. We did add this to our boilerplate. Here's what our fraction class looks like from here to the constructor. Here's what our fraction class looks like, the print and the value methods. Here's GCF's method. Here's the simplify multiply method. Here's the divide method, and then that's the end of the class. And if, by the way, if you put your change me function inside the class, it's not working. So don't do that. If that's where you put them, cut them and put them after the class. And so there's change me and change me too. Now let's take a look at main. main from here all the way. That's the use of the change me functions. And here's where we started using the fractions themselves. That's the first part of it, where we use multiply and divide. I think that's the end of it, actually. Nope, and then we did some pointer stuff here.
We did some weird stuff.
And then we demonstrate, yeah, the real point of this was just to demonstrate that if you have the object itself, you use the dot notation. And if you have a pointer to get the address, you use the arrow greater than. All right, that's about enough of that.